Morning everyone, and welcome to the first part of our geometry review. So we're in the final home stretch, so to speak, for this topic. We're going to have a quick review of everything we've covered through two different parts. So this will be part one, and then we'll be finishing off with a topic test. Right, so through this lesson, slightly different, because you should have been getting your notes and examples in throughout the other lessons. This one here, you won't necessarily need to be copying in notes, but what I will get you to do is, before I answer each question, I'll get you to pause the video and just, in your mind, or maybe with pen and paper, write down what you think the answer will be for the questions, and then, we'll go through it. All right, so on to the first skill. Okay, so, probably easiest question you could get in a test will be, which one of the following is a polygon? Now, remember our definition, polygons are two-dimensional. All the edges are straight. There are no gaps in it. So our polygons here, so pause the video if you don't already know which ones they are, and decide for yourself which ones you think are the polygons here. Okay, so the first one was a polygon. The second one, unfortunately, has a gap. The third one has that curved edge. This one over here, we've got ourselves another polygon here. Onto the second row, yes, we've got ourselves a polygon. This one here, all the edges are straight, there's no gaps, but it's three-dimensional, so that's not a polygon. And of course that last one has a curved edge. It's a circle, so it's not a polygon either. So there was three polygons there. So that's what a polygon is. Now the next type, what we call regular polygons. These are the ones where all the sides are equal, all the angles are equal. Okay, so all the angles need to be the same size, or all the sides need to be the same length. So, what I want you to do is pause the video and determine for yourself which ones you think are the regular polygons. Alright, so in this particular case, we've got different sides, different angles, right? Little angle, medium angle, bigger angle. This one here will be a regular polygon. The diagram actually really isn't the best, but we can see all three sides are the same length because of those dashes, and I'm guessing, it actually will be the case. But based on the diagram, it looks like these angles are the same as well. The next one's a square. That's definitely a regular polygon. All the sides are equal, all the angles are 90 degrees, it's regular. This one down here definitely is not. Here we have ourselves a regular octagon, right? All the sides are equal, all the angles appear to be the same size, and this last one here fails. All the sides are equal length, but the angles are different. We've got a little angle up the top, we've got, bigger angles here, and in the middle we've got some really big angles. So the angles were different there, so it's not regular. Alright, the next part is we've been asked to draw an example of a convex polygon and a non-convex polygon. So the convex polygons, these are the ones where all the different angles or the vertices, they point outwards. So an example of that would be, bang, there it is. If you have a look, every single one of these vertices, they're all pointing out. So this is a convex polygon. Alternatively, if I look at a non-convex, or sometimes what's called a concave polygon, there's going to be one or more of the vertices are actually going to point inwards. They sort of ultimately form like a cave. Bang. So in this particular case, there's only the one vertice that points inwards, but that's all you need for it to be non-convex. So these are all pointing out. This next one actually points in, if that makes sense. So that's a non-convex polygon. All right. Next thing, name the polygon with 4 sides, 5 sides, 6 sides, right up to 10 sides. Okay, pause the video, see how many of them you can remember, and we'll get on with it. Okay, if a shape has 4 sides, lots of people like to name it like a square, a rectangle, maybe a parallelogram, right? These are all examples of 4-sided polygons, but what do we call 4-sided polygons? As in like every single 4-sided polygon, they are called quadrilaterals. Those examples I just said earlier, the square, the rectangle, that sort of stuff, they're examples of special types of quadrilaterals. But if a polygon has 4 sides, it's a quadrilateral. A 5-sided polygon should have had pentagon. The next 6 sides is a hexagon, 7 sides is a heptagon, 8 sides is an octagon, 9 sides is a nonagon, and 10 sides, which is the highest you need to go up to, is decagon. For those that are curious, 11 sides is undecagon, or if like you're looking at like something American, they might call it a hendecagon, and 12 sides is a dodecagon. That's actually as high up as I know. I'm pretty sure there's names for higher numbers, but yeah, you guys need to go up to the decagon. All right, draw an example of each type of triangle. Okay, so for this one here, it's been split into 2 different sides. The left-hand side's based on the side lengths, equilateral, isosceles, scalene. The right-hand side's based on the angles, acute angled, right angled, or obtuse angled. And we need to draw an example of each. So maybe just in your mind, or if you've got your pen and paper there ready, maybe just some scrap paper, maybe have a go, pause the video and have a go at drawing what you think an example of each one of these triangles would be. Okay, so your diagrams or drawings might look a little bit different to mine, but if it has the key features the same, they will be the same. Equilateral. So the idea of the equilateral triangle is every single side needs to be the same length. It's maybe not the best example, but I'll leave it at that. Okay, there's an equilateral. Isosceles. So 2 of the sides needs to be equal. The third one will be different. So we went from equilateral where they're all equal. Now only 2 of them are equal. And the scalene, this is the one where none of them are equal. So ultimately, your goal is just to draw a triangle with all 3 sides having a different length. Okay, an acute angled. So this is just any triangle where all 3 angles are acute. So actually, funnily enough, any of those 3 diagrams on the left-hand side would have worked. So, bang, there we go. There's an acute angled triangle. Again, the key feature of acute is all 3. I didn't realize you could do that. All 3 of the angles are acute. A right angled. Okay, again, it doesn't matter how you drew it. As long as one of your angles was a right angle, that would be marked as correct. And obtuse angled, same, doesn't matter how you draw it, as long as one of the angles is acute. Some people say, hey, what about if you make 2 of the angles, obtuse, as long as one of the angles is obtuse. So people say, what about, if you make 2 of the angles obtuse? Well, I'd actually ask you maybe to try and draw that, and you'll find it's actually impossible to draw a triangle with 2 obtuse angles. You only ever be able to have 1. All right, next page. Okay, so we've been asked to classify these 2 triangles. So there's 2 triangles here. We need to classify them. We've got all the classification names right there on this page. So every triangle will have two different classifications. One from the left-hand list, one from the right-hand list. Okay, so have a quick pause of the video and write down on paper and pen if you're using that, or just in your head if that's how you're doing this chapter review, what you think the classifications of these triangles would be. Okay, so for myself, looking at this, this first one, we've got two sides that are equal. So this triangle is isosceles, and it has a right angle. So it is right angled. The second one, all three angles sides are equal. So this is a equilateral triangle, and all three angles are acute. So it is also acute angled. All right, and the final one, we didn't actually necessarily cover this in any of our previous lessons because this is something you would have covered in Year 7 or Year 8. But sometimes these questions do come up even in a Year 9 exam. So I decided to include it here just to remind you of the different special types of quadrilaterals. We actually spoke about it a little bit earlier in this chapter review. Now we're going to name them. So pause the video. See how many names you remember. So what is there? 6 of them in total. All right, so hopefully you've had a chance to try and name the 6 different special types of quadrilaterals. Either way, let's go through them now. Square, rectangle. The rectangle on the line down here, that's called the parallelogram. And it's because, like, well, yeah, things are parallel. Opposite sides are parallel, I guess. That means they're on the same, like, slope. Up here, most people remember the kite. Or, of course, you could call it a diamond if you wanted. That would also be full marks in an exam. The square on the line, the one next to that, that's the rhombus. Really cool name. That's the square on an angle, rhombus. And the last one's the one that most people forget, but not you guys. No doubts, we all remembered it was the trapezium, right? Okay, so this is actually where we're going to stop our first chapter summary section. In the next link, you'll find the video that's going to cover the second half of this geometry topic. So make sure you go through both these videos. If you need to rewatch any particular parts, feel free to. If you needed to add extra notes into your book, anything that's come up in this video that maybe you missed or skipped, or if you just want to re-emphasize, include any additional notes in your book that you need to, because we will be having topic tests at the end of this week. All right, thank you. I'll see you in the next one.